Hey everybody, this is Larry. This is day 21st of the Leetcode Daily Challenge. Hit the like button, subscribe, and join me on Discord. Let me know what you think about today's forum. Today I've just been chilling. It's a little bit better, still not great, honestly. It's a grind in how frustrating it is. But you know, progress is being made, and that's all you can ask for some days, right? Let's take a look at today's problem. We have 1261, find elements in a contaminated binary tree. Given a binary tree of the following rules, you have the root value, you have any tree node, for every tree node, any tree node, the value x, then left is 2x plus 1, the right is 2x plus 2. Very standard stuff. Yeah, very standard stuff. There are two ways to, this is one common way. The other way is that if the root value is 1, then you have 2 times x and 2 times x plus 1. So, this is right? Like, you know. Anyway, now the binary tree is contaminated. That means all tree nodes change to -1. Okay. Find if true, right? What is the story here? Okay. Obviously, you can reconstruct the tree, right? Or just like put it in somewhere. I don't know. This is kind of a very weird, awkward problem. Have I even done this before? Huh. Well, I was like, I don't remember this even at all, but this as apparently almost 6 years ago, 5.5 years ago. So I don't know. I don't remember it. But the one thing that you can do, of course, is just reconstruct, you could reconstruct the tree as well, but even if you reconstruct the tree, you still need a fast lookup for find, right? So either way, you just have to traverse the tree and pre-cache everything that you've seen, right? That's going to be O of n time, just in linear time, linear search, linear time, just visiting each node once, and a constant lookup for a map lookup, pretty straightforward. So I don't think there's anything too crazy. This part is a little bit, you have to, one thing that I would say is that we have this, these formulas 2x or 2x plus 1 or 2x plus 2. Yeah, if you have more depth, then you have to be really careful because, at least in theory, or in concept as well in certain languages, but of course in Python, you do get big num for free. So you're not really worried about it, except for in edge cases where it is so big that it times out, right? Because big num does have a complexity as with respect to shifting and all these things. And any operation on big num is going to be more expensive than on a primitive, of course. And it is on the order of the number of digits. So anyway, we're not going to get into that much more just because, well, it's not necessary for this one. The height is at most 20, and 2 to the 20 times whatever plus the whatever constant is, like even 3 to the 20 is not that big, so it's not a big deal. Or 2 to the 21 maybe is a better way to think about it necessarily. But yeah, so then we can just construct it. So let's do it. So here in the pre-processing, we have maybe a is it a forbidden, a lookup or whatever, a scene maybe? I don't know. Naming things is hard for me, as y'all know. But yeah, and then we just do a regular traversal, right? And you could do this traversal name any number of ways, right? And maybe current, right? And then we traverse root 0, right? And then here we sub that scene, add current, and then we just, if node dot left is not none, then we just do left, right? Traverse node dot left, current times 2 plus 1, which is what they tell you. And you do the same thing for the right side, of course. And that should be good for the scene, right? For the pre-processing, and then find is just very easy. You just return right target, if I could correctly type it, target in scene, and that's it. Pretty yeah, pretty straightforward, really. You can do this. I did it in depth first search, and maybe that kind of adds up, but you could do this in any number of ways. You could do a breadth first search. You can do iterative based breadth first search or whatever. Traversal is just very straightforward, right? So I don't know. But yeah, this is gonna be linear time, linear space for the initialization, and just all one for fine. So very nice, very tight, and yeah, I'll climb. Even though percentage-wise, it looks sketch, but it's 10 milliseconds. I'm not gonna worry about it. Not gonna give a second thought. And you could probably show that this is lower bound for what, depending on what you want to optimize, right? And what I mean by that is that maybe you can make fine log n if you make the initialization a little bit slower, but I don't know, or faster or something. No, you can really do better than this, and you can really do better than this. So I think this is lower bound for both. But yeah, that is all I have for this one, though. Let me know what you think. I need to take a nap. Stay good, stay healthy, do your mental health. Have a great weekend, everybody. I'll see you out later and take care. Bye-bye.